Number 20 on the 10B, let's see how we can tackle the semicircle problem. 4 congruent semicircles are inscribed in the square, and we know the square has side length 1. Okay, and then we can see here the diameters are on the sides of the square, and we know that one endpoint of each diameter is at a vertex of the square, so that's just saying this basically. And then we have a circle. The key thing is we have a circle inscribed here, and we are basically trying to find the diameter of the circle or the radius, and we'll multiply by 2. How do we do this? So as with any of these circle problems, always draw all important radii. That's something I always like to say. Draw the important radii that go to meaningful points, right? We have this one. I don't know how center that is. Okay, something like that. We draw this radii as well. And okay, I should draw it so it looks... The key thing about these kind of circle problems is that whenever we have two circles are externally tangent or internally tangent, in either case, it's always nice to remember, there's a key property, is that this point, the tangency point, and the center are collinear. And the same thing is true if they're internally tangent, right? This center, this tangency point, this, and the center of the big circle, they're always collinear. So that's something to remember about tangency, right? It's a really useful property. So we have that the center of this, I know it doesn't quite look like it, this point and the center of this circle is going to be in a line. And that's always going to be true, no matter what. And let's just say this is the same thing here, right? And as you can see here, in this other purple square we're drawing, the side length of each of these squares, let's call the radius of the semicircle, let's call it big R. And the radius of this, we'll call it little r. So now we've drawn all our big R radii. Let's now draw our small r. So same thing here. The center of the circle, the tangency point are all collinear. So R, right? R, and same thing over here. R. Cool. So now we're trying to find the diameter of this smaller circle. Okay. Square side length 1. Let's see if we can use that first of all. Okay. So R. Okay, so this is also R. Oh, look here. That's R, 2R, either Pythagorean theorem, or you see this is a 30, 60, 90 triangle. We would get that this length over here is R root 3. And this length is, of course, R. Oh, aha, we can solve for R. R root 3 plus R is 1. So R times root 3 plus 1 equals 1, or R equals 1 over root 3 plus 1. Okay, so now we solve for big R. Let's now see how we can solve for little r. But look here, this is a square. We know this is symmetric, so that's 90 degrees, right? These triangles, they're all going to be symmetric. It's like 4 full rotational symmetry, you can think of it. So R plus R, this is 90, and this is 2R. So that's a 45, 45, 90. So this is really nice here. This is 2R, right, from here to here. So we know that means this is R root 2 by 45, 45, 90. So we have R plus R equals big R root 2. It's confusing when I say R, but this is what I mean here, right? Because this is 2R, this is big R root 2, and it's also equal to big R plus little r. So we have this equation, and that gives us little r equals R root 2 minus R equals R times root 2 minus 1. Okay, and that's nice. So we have equals, and then, okay, let's just first of all find this. What is this? Let's rationalize it. So let's say times root 3 minus 1, root 3 minus 1. Denominator becomes 2, right? 3 minus 1, that's 2. And the numerator becomes root 3 minus 1 over 2. So that means this is going to be the radii of the smaller circle. But we're looking for the diameter, which is just going to be 2 times this, so root 3 minus 1 times root 2 minus 1, and this gives us an answer of 3 plus 2 minus, let's just do it step by step. 3 minus 1 plus 2 minus 1, right? A, B, C, D, A, B, B is negative 1. This should be minus 1 plus 2 minus 1, where this is D, C, D. So A, B, C, D. And then we get an answer of 2 plus 1, 3. So 3 is the answer for this problem. So yeah, it's a pretty neat problem if you think about it. It's not too difficult. All you have to do is draw the radii, calculate big R, and then use some 45, 45, 90 to finish it up. Remember the key property, which is pretty much is really useful for all these circle problems. These points are always collinear. Same thing on this side here. This point, and this point are always collinear. So yeah, I hope you enjoyed this video. Thanks for watching. Bye.